Welcome to this webinar by Jacobs on Hydrology Plus, which is part of Flood Modeler. I'm Adam Parks, I'm part of the Flood Modeler team, and I've been working at Jacobs for the best part of 20 years as an operational modeler, hydrologist, and flood risk analyst. Most of my work involves hydrology for flood mapping, flood defense scheme design, reservoir operations, and flood forecasting. Since joining the Flood Modeler team, Hydrology Plus really has been important to me. So this is addressing some key challenges I felt were in the industry, bringing hydrology and hydraulic modelling closer together. This has progressed massively over the last 6 months. I'm really keen to show you where we are now and where we're going in the future. In this presentation, I'm going to talk you through our Hydrology Plus roadmap, what we're doing, why we're doing it, and what's yet to come. I'll quickly recap on the features in the current version of Flood Modeler in version 7.0. And the bulk of the time we'll be spending looking at what's coming in 7.1. So we're looking to release 7.1 of Flood Modeler by the end of this month, and that will include significant new functionality, including the ability to schematize your catchment within Flood Modeler and create calculation points, undertake and record your WinFAP and RFH analysis within Flood Modeler, making use of Wallingford Hydro Solutions software. We can reconcile your hydrology, apply scaling factors and climate change, and then ultimately apply it directly to your models, both 1D and 2D models, absolutely seamlessly. A large amount of that will be a live demonstration, so I'll talk you through that functionality so you can see what's coming. Towards the end of the presentation, I'll touch on the next steps, what we will see coming through the next few months in Flood Modeler, and then we've got some time for questions and answers right at the end of the session. I suppose first off, why are we doing all this? We regularly talk to our customers and clients across the industry, and they identify their key frustrations. And these things are common across all areas of modeling, but specifically hydrology, these really resonate. When we designed Hydrology Plus, we were looking to alleviate a lot of these challenges that users are facing. Key to that are is better access to data. That's both being able to get hold of data. So there's a massive amount of hydraulic data available to us now. Hydrological gauges, catchment descriptors, and other data are freely available, but actually downloading them, getting hold of them isn't as straightforward as it could be. And once you have access to them, having an intuitive way of visualizing and interacting with that data is really important. A large part of what we want to do, both in Hydrology Plus and more widely in Flood Modeler, is to reduce repetitive steps. The amount of modeling we're doing continues to increase, and there are lots of repetitive steps involved, lots of manual interactions that have to be done over and over again, which is inefficient and time consuming. So by reducing inefficient steps through introduction of efficient workflows, we make it easier to undertake the work and makes it easier to iterate our analysis and getting better results. There are fewer barriers to change. Data management is really important. We're producing more and more data, and improving the way we manage that data is such an important part of what we do, so we can organize and understand our data today and also into the future. And once we've collected that data, generated that data, collaborating, sharing that data both within our organizations, within our teams, and also externally. And all these aspects are touched on by Hydrology Plus. Just having a look at the roadmap for a flood study. These are the typical steps you'll work through. So we start off with data collection, going out, finding what data is available, reviewing it, analyzing it, and doing something with it. We then move on to analysis, and this is where you use external software such as WinFAP and RFH from Wallingford Hydro Solutions. And once you've undertaken your hydrology, you insert into your hydraulic model, and this is where Flood Modeler sits. This is where you can rapidly build your model, generate your simulations, run those, and visualize the results. And then finally, you create your deliverables, you produce your flood maps, your reports, your hydrology proformas. At the moment, we're using different software for all these things. So the data collection is all about downloading, accessing data and storing it somewhere and processing it. Analysis makes use of specialist software like WinFAP and RFH from Wallingford, as well as other tools again to store and process that data. Flood Modeler is used to create the models and run them. And then finally, deliverables are produced, so you can get more specialist data, GIS, word processors, spreadsheets. The aspiration with Hydrology Plus is to make this all streamlined and seamless. So Flood Modeler allowing you to undertake everything from data identification and collection, hydrological analysis, modeling and deliverable production all in one place, making use of key software such as WinFAP and RFH where that adds particular value, and integrating them tightly within Flood Modeler. The key features we're introducing with Hydrology Plus are the database, so a single source of truth, a single place where your data, your analysis is stored, the ability to seamlessly access hydrological data in Flood Modeler to visualize it, access it, and use it, access to FEH catchment descriptors directly in Flood Modeler, the full integration of both WinFAP and RFH2 within the software, and we'll show you that that's really important, and that's the big thing that's coming in version 7.1. And that direct connection, once you've undertaken your hydrology, you're going to directly connect that into a hydraulic model to run your simulations without having to process your data. We'll also be adding a simulation builder, which allows you to take all that hydrological data and produce your simulations quickly and efficiently. And finally, a report builder. This tool will allow you to take all that analysis, all that data you produced, and produce reports seamlessly and efficiently, such as FEH proformas, so you can, again, make it far easier to go from analysis into deliverables. That's the full stack of what we introduced with Hydrology Plus. We started to introduce this with version 7 of Flood Modeler a few months ago, and just to quickly recap on what was introduced then. A key feature in version 7 was the ability to have network licensing for Wallingford Hydro Solutions software, WinFAP and RFH. So we're working in collaboration with Wallingford to allow you to use Flood Modeler network licenses to access WinFAP and RFH software. This software is critical for undertaking UK hydrology. Wallingford have been maintaining it and producing it for many years. And previously it was quite restrictive licensing on a per PC basis, which didn't support flexible working. You can now purchase those licenses via Jacobs and Flood Modeler, and that supports hybrid working. We also introduce access to gauge data, so from both National River Flow Archive from UKCH and the Environment Agency, so you can see all that gauge data in one place. You can visualize it, interact with it, and download it. You can also import and manage your catchment descriptors from UKCH, the FEH catchment descriptors, and you can directly apply your data from those gauges to your hydraulic models. I'll quickly demonstrate some of this in the next section. And most importantly, we've introduced a hydrology database. That's been part of Flood Modeler now since the last version, and that's the place we store all your data securely, and it's well categorized and documented, so there's far more consistency in how we manage our data. Version 7.1 of Flood Modeler is due to be released by the end of this month, and this is a really big step forward for completing the Hydrology Plus roadmap. What we've introduced with version 7.1 is the ability to schematize your catchments. So within Flood Modeler, you can set your calculation points, your flood estimation points up, and record your analysis. You can now manage and update your FEH catchment descriptors. So if you need to edit your catchment descriptors, you can do that within Flood Modeler. And importantly, we record what's done. We've got full provenance chains about who's changed which descriptors and why, and that can be reported on later. You can undertake your RFH 2.3 analysis within Flood Modeler, with that analysis documented and saved in the hydrology database to produce your hydrographs. And the same with WinFAP. Using Wallingford software, you can undertake your statistical analysis of peak flows and document all that information within the hydrological database for future access. We've introduced some really great workflows from taking your analysis through your reconciliation, so pairing up your hydrographs for your peak flow analysis, and then going on to apply uplifts. So for instance, climate change uplifts for the Environment Agency or SEPA can be applied within the software, drawing in the most current guidance. And finally, you can apply the outputs directly to models. There's no more reprocessing your hydrology to insert into models as CSV files or event files. We can connect them directly up within Flood Modeler, providing that seamless end-to-end experience. I'll now give you a live demo for the next 10 minutes or so to just show you some of that functionality within Flood Modeler. What I'm going to show you is some of the functionality that's coming in version 7, and then talk you through all the new stuff that's in 7.1. So how to create a calculation point, how to undertake WinFAP and RFH analysis, how to reconcile your hydrology, and then apply that climate change uplift to it. And finally, I'll apply that directly to a hydraulic model and show you how that functionality works. Just jump into Flood Modeler. So this is 7.1 of Flood Modeler. The interface looks very similar to version 7. And the main difference is under the Hydrology Plus tab, we've added some more functionality as we've expanded. First, I'll just recap on what you could do already. So if I bring some background mapping in and zoom out, so within the interface, the first thing I can do is I can view hydrological data. This is all in version 7, so you can do this now. So we've got two key sources. We've got the National River Flow Archive data from CH, and we've got the Environment Agency's gauge data as well. We are going to add in more data in here. We're looking to add SEPA and NRW data in future releases. So if I want to look at this, for instance, I'll use the NAFRA data and I want to see all the sites in the UK that are okay for pooling, I can just switch that on and I can see every site in the UK I could use for pooled analysis. I can choose one of these and view the data. And what the software is doing is it's pulling in all that contextual information from the National River Flow Archive, so I understand what that station is, how long it's been open for, what the quality concerns are with it, and so on. And I can also view the peak flow data for that site. So I can see across the top, I've got the AMAX record. This is the maximum flow recorded in any given year from the site opening through to present, as well as the peaks over threshold data at the bottom. And we identify we've got missing periods of record or rejected data as well. And quite nice, I can export this as well. So under chart options, I've got the ability to export this data and save it out for use in reporting later on. For England, we've also got the Environment Agency data. The Environment Agency released all their data open source about 18 months ago now. This is a fantastic resource, gives us access to all the gauges for river flow, rainfall level across the UK, across England, and it's accessible by an API, which is what we're connecting to here. So we go up to a site I know well, so let's go up to Cumbria and up to Carlisle. You can see we've got a couple of gauges along the River Eden. So let's look at this one here at Sheepmount. If I click on this, I can see it's a peak flow site, so I can see it's suitable for pooling QMed, and it's also got level and flow data available to it. So if I click on the info button, the same tab appears. I've got all this information about this gauge from its opening in 1967 onwards, information about its rating, and I can access its peak flow data. What I can also do is under observed data, I can pull in more granular information. So initially this is pooling the EA service and caching that data in the database, and it's showing me the last year's worth of hydrometric data. I can very quickly see all the data since that site opened in the 60s, all the way through to today, and I can see the big events. This is showing daily mean data to start with, but if I zoom in on this big peak in 2015, which was Storm Desmond, when I get close enough, it'll load in the 15 min data, the higher resolution data. Once that's cached, I can interact with that. So I can pull off the peak flow data from there. I could switch that to level data. There's a little menu over here to switch between level and flow. I can also export that data. So I want to use that as a boundary for my model. I can export that directly into Flood Modeler standard. So I can export it as an event file, a CSV file, which could be used in 2Flow or other software, or a calibration file to calibrate my model. So I just do that quickly, click export, give it a name. The file's exported. And what's really nice, it loads automatically into the interface. I can bring that in and I can see it there. That's the hydrograph I've just loaded in, as well as the QT data automatically in the right format. So I can bring that straight into a hydraulic model. We've also exported a load of metadata as well. So we know exactly where this came from. We know who exports it, when they export it, where it came from, and exactly which data were exported. So we've got a good confidence, a good provenance chain of where that data's come from. And all that functionality has been available since version 7 of Flood Modeler and should work now in your current versions. Moving on to what we've introduced for version 7.1, I'm going to move to an example site. So I'm going to load in a hydraulic model. This is Upton Pond 7, so a site on the River Severn in the south of England. This is one of the Environment Agency's benchmark models. And we often use this one in training, but it's a really nice site to look at. I've got a model here. I've got at the top end an inflow boundary. So I open that up. At the moment, it's got an inflow boundary of 800 QMEX, and this is demonstration data. But I want to replace this with something more realistic and based on analysis of my hydrology. To do that, I need to undertake WinFAP and RFH analysis at this location. I'm going to show you how to do that all within Flood Modeler. The first thing I'm going to do is bring my catchment descriptors on. So to do this, I need some catchment descriptors. These can be saved in Flood Modeler, so zoom out, you can see all the catchment descriptors I've already downloaded and imported into my database on my PC. I can view those as tabular view as well, so I can see all the data that I've already downloaded into my database, and I can import more by using the import FEH button up here and either do a bulk or a one by one import. In this case, though, I'm going to do my analysis here. So my site of interest is Upton. I've got catchment descriptors just upstream of Upton, and I'm going to use these to do my analysis. The first thing I'm going to do is create a project. So under this H+ project tab, I'm going to click New and create a new project. Provide as much information here as I'd like, so I can give it an alias and perhaps give it the date I'm doing the work. Project reference number, so this could be your organization specific, and a description of what I'm doing. Okay. Already created that example. There we go. So that's created that example file for me, and now it's loaded it in automatically into my project. If I click View Calculation Points, sorry, the first thing I do is create a calculation point. So I've created my Hydrology Plus project. I need to create a calculation point to do my analysis at. I can create as many as I like within a given project. In this case, I'm just going to create one. So I'm going to click on the catchment descriptors, right click and choose create calculation point. This is a calculation point or flood estimation point is another word for them. Click create and give it a name. So let's call this flood estimation point 1 upstream of Upton. Give it a description. I could provide a comment. You'll note it thinks I'm in Wales. I'll talk about why this is later. This is when I get a bit further through the demonstration, and click OK. And now you can see this bullseye has formed, this flood estimation point symbol has appeared. I'm going to switch off the catchment descriptors so I can see it more clearly. And now I can interact with this and do my analysis. So I right click on this and choose calculation point properties. I'm presented with that calculation point information, and I can update this, and you'll note it records who created the calculation point and when. So the software is always logging what's going on to help with data security and data provenance. If I click on catchment descriptors, I can see I've got the catchment descriptors I imported from FEH. I've already created, as part of an earlier project, a new version of these. So I updated the Urbex value, for instance, and this is a really nice part of Hydrology Plus. You can edit your input data, but the software logs what's happened. So for instance, on this one, it may be the area's been subject to a watershed analysis, and I've decided actually it's a bit bigger than that. It's 6,900 square kilometers. I provide a reason for doing that. So it may be click OK, and I can save that change. The software then creates a new version of those catchment descriptors, in this case, the third version. And I can compare them. I can see the differences. So I can see the original and what's changed. And the software is really powerful in that regard. I can also ask it to only filter by changes. So I click changes. You can see the only two catchment descriptors I've adjusted are Urbex and area, or I can look at them all. For my analysis, I'm going to use the default set of catchment descriptors, but if I do want to access any of the other ones, I can do, and it's a really good way of recording what's happened. So these catchment descriptors describe my catchment, how big it is, how steep it is, how permeable it is, and I need these to undertake analysis. The first thing I'm going to do is RFH2 analysis. This creates hydrographs. This is a use of the catchment descriptors and design rainfall in order to calculate a flood hydrograph for me. So I'm going to do this really quickly. If I was doing this in reality, I'd probably, considering the size of the catchment, I'd be very careful about using this method, and I'd also take a lot more time to refine what I'm doing. But in this case, I'm just going to accept all the defaults and finish my analysis. Once I've done this, this is the RFH software from Wallingford, which is opened automatically. Once I'm happy, I click Save, click OK, and then I can exit to Flood Modeler. So that all that data, all that analysis I've undertaken in RFH is recorded and sent back to Flood Modeler to live in the database. And I give this a name and a description, save. And now automatically it's loaded all that data in. I can visualize it. So for instance, I look at the different return periods. I can see the components of the hydrographs and the rainfall within here, or I can choose to see all the different hydrographs all layered on top of each other. And I can come back to this anytime. And if I want to make edits, I can review them in RFH2. I can also export these out. So if I export this data out in CSV format, I can load it back into my model later on. I'm just going to quickly create another version of this. So I'm going to change the critical storm duration of my model. So I'm going to go from 44 to 52 hours, just so I've got two different versions of the analysis, and I'll show you why I want to do that later. So let's save that and send it back to Flood Modeler. It recognizes it's a new version, and I'm going to say this is storm duration 52 hours. I've got two sets of analysis. I can switch between them, and the software updates the plots accordingly, and I can interact with them. I can choose my preferred version, whether that's the default one or it's the updated one with a longer storm duration. That's given my hydrographs. I now need my statistical analysis. So this is using the WinFAP tool. So if I click Initiate, whilst I talk about what's going on, it takes a second to load up. So WinFAP takes observed data from pooling groups and uses that to estimate extreme flows within the river network. And it's absolutely standard software to use in the UK for this analysis. When I click export to this, you can see it's automatically loaded my catchment descriptors in. These will either be the default ones or the edited ones, depending on what I was using. And I can start a WinFAP analysis. WinFAP software is really good and increasingly complex. There's far better training and explanations how this software works from Wallingford's website and online. So I'm just going to talk you through a very simple analysis using WinFAP. What the software has done is it's created me a pooling group, a group of sites similar to the one I was just looking at, in order to create my flood frequency curve. And I've got the ability to edit this. So if I make this bigger, so for instance, it may be if I look at the record parameters and look at the L moments plots, I can see I've got a bit of an outlier site here, 39002. And I may want to remove that from my pooling group, but I wouldn't do that unless I had a good reason. I can do that, so I can now provide a reason. So outlier, and I can remove that from my site and add another station in order to make up the difference. And I can record what I'm doing here. So I've added sheet mount in, and I can put a note why I've added it in. All this data is accessible later on. It's really important we record what we're doing because it can be used later on in our analysis. Once I'm happy with my pooling group, I can look at my flood frequency curves, look at that as a graph. And here we've got the estimates of my extreme flows for different return periods using several different probability distributions, GL, GV, and CAP3. Once I'm happy with this, I can export it to Flood Modeler. So if I go File, Save to Flood Modeler, and then quit WinFAP, when I come back into Flood Modeler, I can import that data in, click Save, and you can see, similar to in WinFAP, I can see the results of my analysis, and they're in tabular form down the bottom. And really usefully, I can also plot on what my RFH2 analysis was. So I can see the difference between RFH peak flow estimate and the WinFAP peak flow estimate. And I can choose to see different distributions. I can choose to look at the urban or rural results. I can turn on and off the RFH. And I can also do more analysis. I could do as many analyses as I like, and they'd all be documented here with comments about how they've worked. Now I've completed that, I can create my hydrographs. This is a really nice part of the interface. So under Hydrograph Library, I can bring my RFH, my WinFAP together. If I click on Add Hydrograph, I've got a new interface. There's quite a lot going on here, but I'll just touch on some aspects. We've got reconciliation and climate change factors. The reconciliation allows me to reconcile my REFH hydrographs to my WinFAP analysis, so I can choose which version of REFH I want to do. So I did 2 analyses. I'm going to choose the original one. I can also choose my WinFAP analysis. In that case, I only had one to choose between, but I've got several distributions to pick. I'm going to go with the GEV one. In reality, you'd spend a bit of time understanding the data to choose the right one. And what the software is doing is it's comparing the WinFAP and the RAFH growth curves and providing scaling factors. So you can see for the 100-year event, RFH gave a peak flow of 1,180, whereas WinFAP gave a lower value, and it's calculated a scaling factor, how much I need to adjust my hydrograph to match. And I can adopt these, or if I want to, I can override them. So if I put an extreme number in here, you'll see what that's doing. It's scaling up based on the numbers I'm putting here. And again, you can provide commentary. And this normally would take half an hour or so to do in a spreadsheet. We can now do it instantly, all within Flood Modeler. I can also apply scaling factors. So if this next tab shows my resultant hydrographs, these are my reconciled hydrographs. I'm just going to look at one to bring a bit of focus, so just the 100-year one in here. Apply climate change, and I'm going to just review the basin I'm working in. The Severn Basin continues across Wales and England, hence it's identified Wales as the country. I'm going to change that. I'm going to choose England, and the software automatically selects the right river basin and the right management catchment. So click OK, and the software's looked up the climate change uplifts that are recommended within that basin by drawing those from the Environment Agency website. And I can choose to apply those. So I can look at the 2050s higher uplifts, and they're applied automatically to my hydrograph. So, and this is all the different return periods as well. So I can look at the 200-year, that's got all those as well. It becomes a bit jumbled. So I'm just going to look at one. I can also apply my own custom factor as well. So this may be 10% sensitivity test. There you go, that 10% sensitivity test is there as well. Once I'm happy with this lot, I click save, and these are saved in my hydrograph library. I can jump back into them by clicking view. I can create new ones, or what I'm going to do is export these out as a set of hydrographs, so I can then bring them into my hydraulic model. So I just move Hydrology Plus out of the way. I'm back in my model, load in my simulation. So this Upton model. So you can see this model's got a single inflow at the top end, and I want to replace that with the hydrology I've just calculated. If I open up my simulation interface, under the Files tab, I've got this box down here which allows me to import that data. So if I click Add, go and find that data I just created and click OK. So these are all the hydrographs I've created, and I can assign them to a node in the model. This model only has one inflow, so I'm going to choose that one. If I had multiple inflows, I could load multiple hydrology and apply it to multiple inflow locations. And what's really nice is I can now change things. So when this model runs, I can choose which return period to run through. So say the 1,000-year, the 100-year. If I had multiple storm durations, I could choose those. Which hydrograph type, so the reconciled baseline, the 2050s, the 2080s climate change, that 10% one, if I choose that one, and other data as well. And when I'm happy, I can save that and click run. The software will extract the right hydrographs from the database I've just generated, run the model, and then I can look at the results. And I can do this really quickly. So if I wanted to run all those different hydrographs, I could very quickly create more and more simulations in order to allow me to do so. So that's all run through nicely. And just to show that's worked, if I look at the inflows to that model, just look at the flow data, you can see it's applied that new hydrograph to that model rather than the default hydrograph that was in the model in the first place.